Hello students, welcome to the next lecture of the DBMS and SQL Viva and interview questions. Let's talk about the question number 41 today. Explain the difference between an exclusive lock and a shared lock. An exclusive lock prohibits other users from reading the locked resource, and a shared lock allows other users to read the locked resource, but they cannot update it. So this is the difference between the operations, read and write operations. So basically, exclusive lock allows a lock on the reading and on the writing, uh, that is on a resource. If a resource on a resource the exclusive lock is acquired, then on that resource no other transaction can perform reading or writing operation. On the other hand, if a shared lock is applied on a resource, then on that resource the other transaction no other transaction can perform a write operation, but yes, other operations can perform read operations. Next question, what is deadlock? How it can be avoided and how can it be recovered once it occurs? So deadlock basically a situation when all the transactions are waiting for each other to release some resources so that they can complete their execution. So deadlock occurs when two transactions or two or more transactions are each waiting on a resource that the other transaction holds. Deadlocks can be prevented by requiring transactions to acquire locks at the same time. And once it occurs, the only way to cure it is to abort one of the transactions and back out of partially completed work. So deadlock is never a good situation for a system. So we have to take care of the deadlock situations. So we try to identify the deadlock situations prior, and if we see that there is a deadlock going to be happen, then we should take necessary steps and necessary measures. And the best way to avoid the deadlocks is using the lock system, the shared lock, exclusive lock systems. And if the deadlock occurs, then we'll have to obviously we'll have to abort at least one of the transactions. But aborting one of the transactions not necessarily means that the deadlock will go away. Maybe we require some more transactions to be aborted. What are the major functions of the database administrator? So database administrator is one of the users of the database who uses the database for the purpose of its administration. Managing database structure, controlling concurrent processing, managing processing rights and responsibilities, developing database securities, providing for the database recovery, and managing the DBMS and maintaining the data repository are the major functions of the database administrator. Obviously, the administrator is very much different from the database designer. So database designer purposely designs the database, where the administrator basically controls the transactions and the database. The next question is about the ACID transaction, the ACID properties of a transaction. So explain what we mean by an ACID transaction, or it can also be asked in the way that what are the ACID properties of the transaction. So the full form of the ACID is atomic, consistent, isolated, and durable. So any transaction must attain these four properties. One is the transaction must be atomic, it must be consistent. That means after performance of the transaction or the execution of the transaction, the database must be in the consistent form. The data transactions must be isolated from each other, and the transaction must be durable. So these are the properties of the a transaction, or such a transaction which attains all these four properties is known as the ACID transaction. Durable means that the database changes are permanent and they are not lost in the duration. Consistently means there is a, if there is a transaction is being executed, then the database should be consistent everywhere. The details, the information should be consistent everywhere throughout the database. The transaction and the next is the isolation. That means the transactions must not interfere in each other. And atomic, either the transaction should be executed completely or it should not be executed at all. So these are the uh, properties of the transaction. Next question. Under what conditions should indexes be used? So if you know, the indexes are the objects that can be created into the database to perform the searching faster. So these are the indexes. Very much similar to the index we found in any book that helps us finding any topic in a faster way. So indexes can be created to enforce uniqueness, to facilitate sorting, and to enable fast retrieval by column values. A good candidate for an index is a column that is frequently used with equal conditions in where clauses. Obviously, the index enables a faster searching of the database, but sometimes it is not good whenever the database insertion and updation are very frequent. Next question is, briefly explain ERD. What is an ERD? So an ERD is a detailed logical representation of the data for an organization. It is known as a entity relationship diagram. The ERD includes entities, their attributes, the relationships among entities, and cardinalities. An ERD is the mechanism where an entity relationship model is displayed, how one entity is related to the other entity and what relationship they follow. So just to depict this relationship between or among the entities of the organization, we form entity relationship diagram. What is the difference between ERD and EER? So the full form of ERD, as we know, this is a entity relationship diagram, and double ER is the extended entity relationship diagram. So an double ER includes everything in an ERD, and an double ER allows for more complex relationship than an ERD. So the relationships can be further classified as aggregation, specialization, generalization. So whenever we display all these special relationships and the complex relationships in the diagram, then the diagram is known as the extended ER diagram, that is double ER. And double ER allows for object-oriented data modeling and includes supertype and subtype entities and interfaces also. So sorry, the inheritance also. So whenever the special relationships or complex relationships are represented into the diagram in the entity relationship diagram, it is known as double ER, that is extended ER diagram. Next question. Explain some of the main goals of normalization. So we have learned the normalization. It is the process of decomposing and composing the tables. Normalization should minimize data redundancy. This is the main objective, main goal of the normalization, to minimize the data redundancy. It should also simplify referential integrity constraints, and normalization will also make it easier to insert, update, and delete data. And finally, it provides a better design. So whenever the tables are in normal form, the database will be in consistent form. This is more probable. So the major goal of the normalization is the data redundancy. Next question is, list some properties of the relationship. Relation properties. The relations in a database have a unique name, and no multi-valued attribute exists into the relationship. Each row is unique, and each attribute within a relation has a unique name that is identified by the unique name. The sequence of both columns and rows is irrelevant into a table. Which column comes first, which column comes last, and which rows come first and which row come last doesn't matter into the database. So the relationship has to be a unique name. The attributes must also have unique names. This is the relationship. What needs to happen to convert a relation to the third normal form, 3NF? How you can convert a relation to 3NF? The primary condition of a relation to be converted to 3NF is that it should be into the second normal form, and the transitive dependency should be removed from the tables. So these two steps we'll have to perform. One, we need to convert the table into the second normal form, and we need to remove all the transitive dependencies present into the table structure. Next question, describe domain constraints. We have learned about the constraints, which are domain constraints, referential constraints, integrity constraints, entity constraints. So what are the domain constraints? Domain constraints include entity integrity and referential integrity. The domain is a set of values that may be assigned to an attribute. The entity integrity rule states that no part of a primary key cannot be null. Referential integrity states that each foreign key value must match a primary key value or a null value. So the domain constraints, referential constraints, and integrity constraints. What are the four objectives of the selection of the data type? A data type should be selected so that all possible values are presented using minimal storage space. This is the first criteria, that it should use minimal storage space. It should help to ensure data integrity and support all possible data manipulations. So the next is the integrity and manipulations. So these are the requisites. These are the requisites of the data type selection. Describe the four type of indexes. We had already had a talk about the indexes and when the indexes are required, what is the requisite of the indexes. Unique primary index is a unique and is used to find and store a row. A mono-unique primary index is not a unique and is used to find a row, but also where to store a row based on its unique primary index. A unique secondary index is a unique for each row and is used to find table rows. And last is non-unique secondary index. That is, a non-unique secondary index is not unique and is used to find a table rows. So we have learned about these four type of indexes. One is unique primary index, second is non-unique primary index, then is the unique secondary index, and the fourth is non-unique secondary index. What is denormalization and why we should someone consider doing so? We have heard about the term normalization. So just the vice versa of the normalization, or the reverse process of the normalization, is known as the denormalization. So denormalization is the process of taking normalized relations and changing them so that they are not, or they are no longer normalized. This process may lead to anomalies and create data redundancies as negative consequences. However, the revised relation should improve database performance. So there are more negative impacts of performing denormalizations. These negative impacts are the introduction of the anomalies and introduction of the data redundancies. But there is one positive impact also, that just by performing the denormalization, may the database performance improves, because it has not to bother about the referential integrity constraints. It does not have to connect relations, does not have to depend on the relationships. So the performance of the database improves. So that's it for the lecture. We will discuss more questions into the upcoming lecture. Thank you so much.